There are three main categories associated with green building. First is energy efficiency and generation. This is the one that most people pay attention to because it is quantifiable. You can have metrics, you can find out what the payback period is, meaning if you invest $10,000 in solar panels and they save you $1,000 a year in energy, the payback period in the simplest terms is 10 years. It's also something that building departments are able to regulate easiest. They can actually, just like the MPG rating for your car, they can do the same thing for your house. Here in Boulder we do. And the codes that we've evolved in Boulder tend to be just a couple years ahead of Loveland and Denver and some of the surrounding municipalities, but they do tend to be adopted elsewhere. So what in Denver may currently be an optional thing to do, here is already current code. So when we build a house, you cannot build a house in Boulder that is not green. It is not possible to get a building permit. And the primary area that this is measured and controlled in is energy efficiency and generation. Second is environmental quality. IAQ stands for indoor air quality, which is the most common or the largest subtopic within the environmental quality category. Environmental quality refers to everything. It's climate change, it's pollution in the air, but the place that most people actually feel it is the indoor air quality. What Matt was talking about at the beginning about that they use non-toxic finishes for all of the cabinets here, that is one of the 100 different components that contribute towards indoor air quality. And we'll get into that in a little bit. It pertains particularly to human health, and then the larger environmental quality is the health of all living organisms. The last one is resource conservation. This one can be best expressed with, if you build a house but have to cut down the forest and your children have no place to play, it's not necessarily a good deal. So we're looking for materials, and there are a lot of materials in this room that are sourced from, as you're saying, sustainably managed forests, where they can get a certification label that says that the forest is designed so that it's not a monoculture, they're not clear cutting, and it is possible at this point to actually build a green home that is not a compromise. And what I mean by that is, 15 years ago, if you said, I want a green home, there were certain things that you were probably going to have to let go of. Some of the fancier finishes or maybe more, the durability of it. These days, the market has actually gotten to the point where you don't have to compromise on green building. You can have a building that is beautiful, functional, durable, and sustainable all at the same time. One little caveat, and this is something as potential homeowners, home buyers, remodelers, developers, that you might want to know, green building still does cost more. The greener you go, the more it costs. It's a premium, a little bit like buying a Tesla. But what's happened is that over the years, the market has evolved, and where things used to be super premium. 20 years ago, when Home Depot rolled out the first non-toxic paint, it was 10 times the cost of regular paint. Their low VOC paint right now is the exact same cost as their regular paint, meaning their healthy indoor air quality paint is the same. And that's how the market tends to evolve. It takes a little while, but at this point, you can actually build a house for very close to the same cost as a conventional house, and you can do it green. Things to remember in order to build a greener home. Reduce building size. The less you build, the less resources you're using, the less energy you're using over the life of the building to maintain it. This is the number one thing you can build, is right-sizing the home for yourself. There's a wonderful series of books called The Not So Big House. You might want to check them out. You can find them in any bookstore, and they are just a delightful read written by an amazingly lovely person who just talks very simply about, do you really need a dining room as big as this entire showroom, or can you have one that's the size necessary for you and your family instead? It's one of the nice parts about co-housing is that you don't actually have to have the Thanksgiving-sized dining room because you have a common house that can handle your Thanksgiving. The HERS rater, who knows what a HERS rater is, or HERS is? We have one. Okay, HERS stands for Home Energy Rating System. It's a brand of something called the ERI, the Energy Rating Index. Energy Rating Index is an MPG rating for your car. The equivalent is an ERI rating for your house. But unlike an MPG rating where you want it to be higher in order to be more sustainable, with a HERS rating you want it to be lower. And we'll go into this in detail in just a little bit. Passive solar is one of the only things you can do for your house that doesn't cost a dime more and dramatically saves on your energy costs, somewhere typically between 25 and 50%. It has to do with the orientation of the house, the size and location of the windows, and how you protect them. The building envelope, this is your puffy coat and your warm hat and your warm boots. We're going to talk a little bit about what you can do to give your house a really good envelope. And the passive house that you mentioned is a program that features that particular aspect of green building. Active solar and renewable power. One of the quickest ways to lower your HERS score, to decrease your energy bills, is to obviously put solar panels on the roof. Around here, that's the most common application of renewable power. But you can also do solar hot water. Theoretically, you can do wind. We don't have great wind in the Boulder area, but as you move further east into the plains area, wind becomes more viable. And there's one other that is sort of a renewable power that we'll talk about later, called geothermal, or better yet, ground source heat pumps. The advanced mechanical systems, ground source heat pump, is the quintessential version of that, but these days there are super energy efficient conventional systems as well for a fraction of the cost. We'll go into those. Advanced efficient lighting and appliances, especially in the kitchen, but everywhere in the house where you have things like LED lights or compact fluorescent lights are on their way out. They contain mercury. It's an older technology. Within a few years, they're probably not even going to be sold anymore. They're rapidly being replaced by LED lighting. The original price of LED lighting 10 years ago was astronomical, but it's been falling off a cliff, and the lighting quality has been getting much better as well, so that at this point the color rendition in a house or in any building is going to be nearly the same as incandescent lighting. So we've gotten to a point where LED lighting has now reached a point of maturity in the building industry. The appliances are often marked by something called the Energy Star label. This is an EPA program. It's that little blue box with a little white star on it that you've probably seen. If you go into Home Depot and you see the Energy Star label, it's a little bit like the organic certification in that once you see it, you know that it meets certain minimum criteria. Within that, there are levels of sustainability or energy efficiency, and we'll go into that in just a little bit. Again, we talked about indoor air quality as being the most important to you in most cases, meaning it's the least abstract. When we're talking about environmental quality, if you're saying, well, we get our energy from our solar panels or from natural gas instead of from a coal-fired power plant, you are absolutely helping with environmental quality. But it's a little bit abstract, meaning the power plant is probably not sitting right by your house. When we focus on indoor air quality, we're talking about that your personal health will be dramatically and directly, immediately impacted by the amount of formaldehyde in the cabinets and the flooring and the paint and the carpet. Understood? Okay. Green materials, this again is things like recycled countertops is a really good example of that. Resource conservation, again, there are ways to harvest timber or all the resources that we bring into the house and use to build the house that can decrease its total environmental impact. Just so you know why this is an important topic, of all the sectors out there, industry, transportation, buildings are actually the largest consumer of energy and the largest carbon impact in the world. It's buildings, not transportation, not industry. And of that, the largest sector is residential. Houses have an enormous impact on sustainability, more than any other single sector of the economy, period. Here in Boulder County, we're looking at 25% of the total CO2 that's emitted. You know, Boulder has a climate action plan that says that we are going to try and get to carbon neutrality by 2030, and this is letting you know that houses are an enormous part of that equation. This is one of the most important things for you to know because it will apply to the home tour really specifically. This is how we understand the energy efficiency of a house. This is called a HERS index or HERS rating. A HERS of 100 is the maximum amount of energy allowed by code per square foot according to the International Building Code, which is what all municipalities around the entire country use. Each individual municipality can then overlay on top of that additional requirements. Boulders are some of the strictest in the whole country, and we require that you dramatically beat that number. So you can't use 100% of the allowed energy per square foot. In Boulder, depending on the size of your house, you have to be somewhere down here. For example, in Boulder County unincorporated, if you build a house 5,000 square feet or larger, it has to be net zero energy, which means a zero on this scale. There are lots of older houses. So say a 1970s house in Martin Acres, one of the standard kits, Sears and Roebuck houses, those tend to have a HERS rating of about 190, which is why you have $500 a month energy bills for a 1,000 square foot house. You can remodel those. Matter of fact, the worse something is, the more impact you can have to improve it, the more low-hanging fruit there is to improve the house. So don't fret if you happen to live in a house that has terrible energy bills. We can do a lot to improve it. If you're building new, though, you can get all the way down here, and in Boulder County, in the city of Boulder, you're actually required to go down there just to get your building permit. There are a lot of ways to get there, and we're going to describe each of those. So does everybody understand this general chart? So if I say this house has a HERS rating of 95, and I'm very proud of that as a new builder, should I be proud of that? No. Probably not. That means it's a pretty bad house from an energy point of view. If I say this house has a HERS rating of 10, should I be proud of that? Darn tootin'. So just so you know, as you go to real estate showings, very often they will have this, a home energy rating certificate. And you'll see all these stars up here, and you'll be like, "Ooh, wow, that's great! It's 5.5 star." Just know that you can get a 5-star rating for your house with like a HERS 90. So don't be too impressed by the stars. Ignore that little graphic and look at this number here. This is actually a negative number. Negative stands for a regenerative house, meaning a net zero energy positive house, one that makes more energy over the course of a year than it consumes. This is the wave of the future for cutting edge green. You've probably heard of the term net zero energy homes. It became very common about 5 years ago. That is still incredibly hard to get to. But the new benchmark that we're shooting for is called regenerative homes, which is the next evolution of green building. We're going to go back one. Just so you understand what makes up a HERS rating, how do you get there? We plug everything having to do with energy in home, the lighting, the mechanical systems, the appliances, the insulation, the solar orientation, the windows and the size of the windows into this box. And HERS Rater, this black box program, HERS Rater takes all this and puts it into a model and then predicts what your energy usage is likely to be over the course of the year relative to other strategies that you might have for the house. If you turned it 90 degrees, if you changed the insulation or the windows or the appliances or the lighting. Then the HERS Rater does something else. So that's the first step, the from plans rating. Then once you're building the house, a HERS Rater comes out and inspects your insulation as it's being put up before the drywall goes up so they can actually see how well it has been installed. The next step is they do, at the end of the building process, the blower door test, where they pressurize the house with a giant fan to see where air is leaking out and how fast. They also use other techniques like an infrared camera, where they can actually see almost an X-ray picture of all the walls to see the differential in heat temperature between different parts. So windows will be one color and walls where there's a lot of insulation will be another color. A HERS Rater can come in and help you to analyze and audit an existing home, or to help you to plan a new home from scratch. Then at the end, they issue a HERS certificate, which is your third-party certification. And this is a really important part. We'll talk about this in a little bit broader context later. A home is only as green as it is tested. And what that means is lots of people will say, "This is a green home." You don't know it's green until you have a third-party certify and test that it is, whether it's the materials coming from a sustainably managed forest or the energy efficiency of a house. So look for those third rating certifications. These are some of the most common. LEED is Leadership in Energy Efficient Design by the U.S. Green Building Council. It tends to focus more on commercial institutional projects, but there is a LEED rating for homes as well. And it goes silver, gold, and platinum, or actually certified first is the lowest, and then silver, gold, platinum for different levels of certification. LEED is different from a HERS rating. HERS only measures the energy use of a house. LEED measures the entire sustainability package of a house. Its water use, how it deals with the land and landscaping, where the materials come from, how much waste is generated, the location of the house, and how it relates to your transportation needs. All of those things go into the LEED rating. Energy Star tends to be focused, as the name might imply, much more just on the energy. This is an EPA program. It's one of the big national programs, and it does a really good job of tracking all the details of energy use in a house. This is the Passive House Institute. Some of you may have heard of it. It is probably the most rigorous for dealing with the use of energy through the envelope of the house. Meaning LEED looks at sustainability very broadly and comprehensively. Passive House focuses just on how thick is your puffy coat, how good is your hat, things like that. It's from Germany, and it really sets the benchmark for reducing air infiltration and making sure that if you have a candle, you can heat your house. Yeah.
How many passive houses, certified passive houses are in the Boulder area?
I don't know, but the answer is very, very few. I would guess you can count them on 2 hands at absolute most. It might even be 1 hand. It's a very high benchmark to reach. Yeah.
When I think of a passive house, I think of like one made out of mud bricks,
Mm-hmm.
or
So.
one made out of straw bale.
Mm-hmm.
So how does that fit in with that?
They can retrofit houses.
Yeah. So theoretically, you could probably have a straw bale passive house. Most passive houses, it's a German program, and they tend to be focused on more of the high-tech rather than the low-tech side. So it tends to be things like triple-paned windows because they're incredibly highly insulated. Their U value is super, super low. And we'll talk about U value in a moment. A lot of foam in the walls and outside the walls to help really insulate the house. Those tend to be strategies associated with passive house. I don't know of any passive houses that are straw bale, but theoretically, a straw bale house could be a passive house.
My mother lived in a house that had, like double or triple windows,
Mm-hmm.
and they would get foggy periodically
Mm-hmm.
after a certain period of time.
Yeah, that's a window that's
Yes.
failing. Yeah, the gasket has failed. Those
Yeah.
windows have to be replaced.
And they replace them every once in a while, and they are very expensive.
Yes, they are. Windows are some of the most expensive elements of a green home. The last one, the National Association of Home Builders. Architects, engineers, builders, all different parts of the industry have taken a shot at creating the official green building program. Everybody has a different angle towards it, and they're all perfectly good programs. But LEED is probably the best known of all of those outside of the HERS rating system itself. One thing to note about why we're talking about this, if you happen to live in LA, how do you make a green home? Well, you probably put some solar panels on it and open up the windows and doors. It's 70 degrees. You don't need insulation. You barely need a mechanical system. You need to generate some electricity for the occasional air conditioning and some lighting use. That's about it. Here in Boulder and in Colorado in general, we're in this zone right here. The different colors represent, as you can see, the harshness of the climate, the amount of what are called heating degree days that are necessary to keep your house thermally comfortable. But unlike being way up here or way down here, we're in a unique position here where we have during the summer 100-degree days and incredibly strong sun, and during the winter nights we have -10-degree days. None of these other places deal with such an enormous thermal variation. So we have an unusual situation where we don't have to be good just at keeping warm or just at keeping cool. We have to be equally good at both of those extremes. So Colorado is one of the most difficult places in the entire country to have a thermally efficient green-built home. Just in case you're wondering where you are losing your energy in a house or where you're using it, air infiltration. This is one of the least sexy places to talk about in green building because what you're talking about is getting there with a caulk gun and filling in all the little gaps. This is something that an energy auditor or energy rater can help you with because they trace energy as it moves through the house. They can find the air infiltration points, the draft spots, the places where insulation was not properly installed in a house. So for about $3,000 to $4,000 on a typical, call it 2,500 square foot house, you can have somebody come in and do an air sealing package where they come in with a caulk gun and do window stripping around windows and things like that. It's not sexy like photovoltaic panels on your roof, but it has an enormous and a very low cost impact, or it's a low cost way to dramatically impact your energy efficiency. Walls, this is insulation in the walls, so you can simply add more insulation. Lots of houses have really poor insulation. If you have fiberglass bats in your walls and you have 2x4 walls, I guarantee you have places in your walls where there is no insulation at all. Even if the builder said, oh, we put the insulation everywhere. There are pipes and electrical conduit, and there's blocking in the walls, and it takes up the space of insulation. Also, the walls themselves, the 2x4s or 2x6s of your walls, are what's called a thermal bridge, and heat actually migrates across them very quickly. So in the center cavity of your stud wall, so if you have a 2x4 and a 2x4, in the center you may have a great bat of insulation, those big pink fuzzy fiberglass bats. And you might have an R21 wall at that point, meaning that it's a really good energy efficient wall. But at the studs, the fiberglass is probably compressed, there are probably leaks, and equally importantly, the studs themselves are only about an R3. They conduct energy very quickly from one side to the other. So if you've ever looked at a roof on a frosty day and you see these white stripes on the roof, that's because heat is being conducted through the frame of the house. Windows, as I mentioned before, they're a big hole. Windows tend to be about an R3 in general. Walls are an R21. Windows are a big leak point for energy, and it's a great place to improve your energy efficiency, but they're also one of the more expensive places to upgrade your energy efficiency. And then lastly, we have the roof, where it's actually pretty easy to put in a lot of additional insulation, even if you have insulation in place. The floor and the slab, this is one of the harder places just because you can't get in and get under it unless you're building new, or you have a big crawl space. This is what I was talking about before, the infrared camera. This is what you see when looking with an infrared camera, and you can see the thermal temperature differential. These are radiant heat loops in the floor. This is a place where insulation is fine in the walls, but as it comes up to the sill, it gets compressed and there's air leakage. You can almost see the air coming down the wall. This is a recessed can in the ceiling. Josh, can we turn the lights off? This is a recessed can in the ceiling. These are windows, and this is an attic crawl space hatch where they don't have insulation. Thank you. Much better. So just know that in retrofitting a house, there are lots of easy, low-hanging fruit spots to actually dramatically improve the energy efficiency of your house. For a relative understanding, it's important to understand that there are lots of different kinds of insulation, lots of different ways to seal the house, starting from the least expensive, and you can see the dramatic difference in cost, but also the lowest R value per inch. R value per inch is the thermal resistance per inch of a material. The higher the R value, the better the material for insulation. Fiberglass bats, theoretically 3.1, but the problem with fiberglass bats is they're almost never installed perfectly, meaning you almost never have two 2x4s and you can staple them right up to the sides and there's nothing compressing the bat. They're almost always compressed. When you have a compressed bat, you have air that's circulating in that space, and it really ruins even that mediocre R value. So just know that fiberglass bats, good for garages, not so much for anything else. EcoBat, this is just a particular brand that's a little bit better from both the material that's used, the reduction of formaldehyde, and a slightly better R value. Cotton and mineral wool, this is typically used for acoustic batting inside of a house. It's a natural material, so if you have an environmental sensitivity to formaldehyde, this is an option for you. The blown-in fiberglass, this fills the cavity very well, and I like it as a product for insulation. It has a downside that microfibers tend to spread all throughout the house during the insulation process, and they can get into your lung tissue and cause irritation and asthma and things like that. These are the extruded polystyrene. This goes on the outside of a house. These are these big sheets of flat foam. They almost look like a giant wafer. And they're typically an inch. You can get them a little bit wider, a little bit bigger, and they have a terrific R value. They really break that thermal conductivity from the frame of a house. So as I was saying before, that thermal transfer happens in the frame, the studs of a house. This is one way to break it. So the houses that we design typically have an inch of rigid insulation wrapping the entire envelope of a house. It's a really great way to insulate your house. It's a little bit expensive though. Wet cellulose, you've probably seen cellulose that gets sprayed in. It's chopped up newspaper with a binder, and it gets either wet or dry spray into the wall cavities. It's a good use of recycled renewable material. It fills every nook and cranny, and it's a fairly low cost one. If you're doing a modest price installation where you're looking for good energy efficiency, this is one of our favorites. These two foams right here are the best insulation. Open cell spray foam doesn't insulate as well, but it's a lot less expensive than the closed cell spray foam. If you're looking for maximum energy efficiency, something like a passive house or a net zero energy house, you really need to be using these, in many cases, plus the exterior wrap of the extruded polystyrene. Yes?
My termite guy says that the polystyrene, all the puffy stuff,
Yep.
termites just love that stuff.
Really?
My sister was in California, and she had a pump house
Mm-hmm.
that had a roof, a ceiling that had, that kind of stuff
Yep.
all over the ceiling. And they had just a gazillion termites in there.
Good to know. Fortunately, in the Boulder, Denver metro area, we have almost no termites.
Oh, no, you do. Yes, you do.
Okay.
In some neighborhoods,
In some neighborhoods. Interesting. We have not run into termite problems anywhere in our practice yet. I guess we're lucky so far. But it's good to know. I didn't know that they feed on the foam.
Well, no, they like to live in it.
Oh, they nest in it.
They nest in it. They like to make their tunnels and fall.
Yep. Actually,
He said, don't use foam. Use mineral wool.
Yep. Mineral wool is the only.
Get mineral wool?
You can. It's it's expensive. It's pretty much the only material that isn't a food or a nest for something.
Yeah.
So there are different ways to frame a house. This is a particular technique called optimal value engineered thermal bridging or framing. And what it says is that you can throw a lot of wood into the walls of a house or a little bit. And it has to do with how much attention you're paying during the framing process. In general, we're talking about custom homes, whether it's a remodel of an existing home or a new home. Interestingly, this is one of the techniques that was developed by the spec production home builders, the guys that build 1,000 houses at a time out on the prairies, because they're able to actually look at how are we going to frame 1,000 houses. And if we can save $100 on each house, suddenly we saved $100,000. So to them, it made a huge difference, and they started to pay very careful attention to how to be as efficient as possible. They did it for economic savings, but it wound up having a byproduct of sustainability at the same time. So it's a byproduct of being more sustainable because it's using less lumber. So this is a technical thing that typically your builder or framer or structural engineer would be able to help you with. Here's a system that last year on the Green Building Tour we had the Red Oaks Park, which is right over here at 30th and 28th and Valmont. They have a system called the double wall system. We built a house this way last year where you actually have two walls and a big space between them. It's a very, very thick wall. And then you can fill it with cellulose or a blown-in bib insulation and fill up this huge cavity with one of the less expensive insulations that doesn't have as high an R value per inch, but you're giving it more inches. It tends to also create an old world, almost European look to it. But it does take up some square footage and adds to the cost because you're essentially framing two walls, one on the inside, one on the outside.
On the double wall thing, I always thought they staggered the studs.
That is one way to do it. So this way is two walls actually set apart, but in a less expensive way to do the same thing, a clever way is you take a 2x6 base plate and then you have a 2x4 and a 2x4 and you don't align them, you stagger them just a little bit and it creates a continuous 6-inch wide cavity in between. One thing that you'll probably hear as we go through this, there are a zillion ways to skin the cat, meaning different ways to reach sustainability. Lots of folks will say, this is the only way, passive house or passive solar, whatever. There are lots of different ways to achieve it. And there's no perfect solution, not one perfect product, not one perfect technique, but there are lots of good ones. And it's important to design holistically when you are doing green building, because you're looking at how the whole system works together. And then when we work with folks, the first thing we're looking at is what are your goals? What's your budget? What's your timeline? What are the things that you're looking for your house to do? How's it going to perform? Because each of these techniques has various advantages and disadvantages. We built with straw bale a few years ago for a client, and we did it because the client said, we want to help build the house ourselves. That was an important value for them. It isn't the least expensive way to do it, even though they built some of it themselves. But they wanted to have the satisfaction of building that particular way. So every time we recommend a particular strategy or concert of strategies, we're looking at it as a whole system. Does this particular energy system work with this framing system, work with this insulation system? This is a unique one. It's called insulated concrete forms. They're giant Lego blocks, hollow in the middle, that you fill with concrete. It creates a high thermal mass product, and I'll explain what that means in just a little bit. But there's an advantage to it. It's a very heavy building, and that has some particular benefits, like straw bale. It's also fireproof, soundproof, and it's a very solid feeling house. It's not, it's foam, and then you pour concrete into the foam.
The foam's not plastic.
No.
What is it?
It's made from petroleum, so it's made from the same thing as plastic, but plastic is a different kind of derivative of petroleum. So I was talking about the thermal mass, or the massiveness of an insulated concrete wall. Similar to, so adobe, insulated concrete forms, and straw bale all share a similar property. If you picked up a section of it, it would be really heavy. If you've ever been out camping and you know that, say 10 o'clock at night, if you put your hand on a big rock, it may be 40 degrees outside in the mountains, but the rock is still going to be 70 degrees. In the morning when you get up, at about, let's say 11 o'clock in the morning, it might be 80 degrees outside, ambient air temperature, and you put your hand on the rock and it feels nice and cool. It's because the rock is so massive, it has this thermal mass, that it has a thermal lag, meaning it heats up and cools down very, very slowly. Same thing with these massive wall systems. So, for example, yeah?
Could I ask a question?
Oh, sure.
How can concrete be green?
We'll talk about that a little bit more in a moment,
Okay.
but concrete in general is made from sand, water, aggregate, and cement. Sand, water, and aggregate are all very common and non-toxic, low-embodied energy products, meaning the amount of energy that it takes to harvest, transport, and build them is fairly small. The cement, on the other hand, which typically comes from the Portland area, is a very high embodied energy material, and there are ways to replace parts of it with something called fly ash. Fly ash is the byproduct of coal-fired power plants, and you can use a certain percentage, usually about 10 to 15% maximum, to replace Portland cement with the fly ash. So you can use what would be a hazardous material waste product that goes to the landfill and replace some of this high embodied energy Portland cement. That's about the only way to make a green concrete. Does everybody understand all that? So you're actually, with some of the insulated concrete form buildings, you're not necessarily using that much concrete. You can see it's mostly foam with just a little bit of concrete in the middle. But in general, wood versus concrete, wood is a lower embodied energy renewable material, concrete is a higher embodied energy material. Differences, and we saw from the hurricanes that just blew through, that we're also looking at the durability of the overall home. If you build a home that lasts for 200 years versus a home that lasts for 50 years, the 200-year home is inherently greener than the 50-year home. But sometimes you have to invest more materials, whether it's the embodied energy or the toxicity, or there are a wide variety of things that you often have to put into a home to make it more durable. Because durable in most cases means resistant to the forces of nature, whether it's wind or water or freeze or thaw. And typically those materials and those systems are more robust, take more embodied energy, and require more materials and resources to make the house more resistant to the natural forces. So going back to this interesting little diagram, this right here is the internal temperature. And what it's showing is that this is the outdoor ambient air temperature, and that this guy right here is the indoor temperature that is modulated. Well, in a high thermal mass house, it takes longer for the house to heat up and cool down. So if you have an insulated concrete wall or an adobe wall or a straw bale wall, it just takes a long time for that much mass to heat up and cool down. So the house does what's called coasting. So it can passively stay comfortable and habitable for humans without the introduction of a lot of outside air temperature. At the very beginning, I mentioned that we are in a unique climate, lots of high heating days and cold nights. And that's both seasonal and diurnal, meaning from day to night. So we have cold nights and warm days on the same day. This particular strategy of a high thermal mass building actually works particularly well here in Colorado, because what happens is it gets cold at night, cools the building down, but the building stays nice and warm for most of the time that it's dark outside, and it reaches its lowest temperature just as the sun is rising. So as the house starts to heat up, you've gained all this natural cooling effect from the cool outdoor air. And the same thing happens during the day, that the house starts to warm up and then it stays warm throughout the night. So that's the thermal coasting or thermal lag. Another product is called structurally insulated panels, SIPs. These are like Oreo cookies. Oriented strand board on the outside, foam on the inside. Oriented strand board is made from little chopped up, typically aspen and poplar trees, fast growing trees that are set into a binder, a resin binder, and turned into a flat plate of, like plywood, turned into a flat plate of board. It replaces older ways of building that utilized bigger old growth trees. If you wanted to build a house 50 years ago, you might be using planks. And if some of you lived in, actually a little bit more than 50, but if some of you have lived in historic homes, you might know that there was lath and plaster, where they actually took a strip of solid, typically old growth wood, and then plastered over it. Building a house sheathed with actual big trees has a high environmental impact, especially now that we don't have as many trees, or we're building lots more houses. We're building over 1 million houses a year in the United States. If you imagine that each house is going to require a section of a forest, you can quickly see that we're going to be cutting down forest too quickly if we're using old growth lumber. So the forestry and lumber industry has been saying, we can't keep up with the demand. Let's come up with new ways to fabricate products that have never been seen before. Plywood was one that came out 50 years ago, and 20 years ago they came out with the newer generation called oriented strand board. The nice thing about both plywood and OSB is that they are structurally predictable. You know exactly what their engineering capacity is, so you can use less of it. When a structural engineer doesn't know what the structural properties of a piece of wood, any natural material is, they have to overcompensate because there might be a weak spot. But with something like this,
Is that polystyrene in the middle? What's the middle?
typically, yeah. With any engineered lumber product like this, it has measurable structural properties so that they can use a little bit less of it. Thinner members, which means less trees cut down. The advantage of SIPs is that it goes up very, very fast and creates a tight envelope all the way around the house. It does tend to be a little bit more expensive than conventional framing, though.
And that's a non-toxic binder?
No, it tends to be a toxic binder. Almost all of the engineered wood products and the foam products off-gas volatile organic compounds of different sorts. Some of them largely cure by the time you move into them, but some of them, like particle board and cabinetry, and you guys probably know this, can off-gas for decades. So certain types of products can have a strong negative impact on your personal immune system, particularly your respiratory system. The thing about these products is that they have the ability to off-gas most of the volatile organic compounds before they reach your house, meaning they're not interior finishes. There are certain things like the floor finish or cabinets that tend to go in towards the very end, once the house is already sealed up. Things like OSB tend to be happening when the house is wide open. You don't even have windows in, so the house is able to off-gas most of the toxic chemicals into the air.
How many months would you say?
Depends on the product.
The SIPs?
SIPs, 3-4 months.
And that's like 60%, 70% of it?
I'm not a chemical engineer, so I really couldn't tell you. Actually, there's a really easy way to know. This might sound overly simplistic, but if you can smell that new carpet smell, that new house smell, even that new phone smell or new car smell, you are smelling the off-gassing of volatile organic compounds. It's actually a surprisingly dumb way to recognize it, but you don't need any specialized technology to know whether or not it's off-gassing. Yes, so there is a group of people, and we'll cover this a little bit later, that are called environmentally sensitive or have environmental illness or sick building syndrome. And those people essentially have an allergic reaction, an overwhelmed immune system by the cumulative impact of the toxicity in buildings. We spend about 90% of our time indoors, so the quality of the air of the space that you inhabit is the single largest impact on your health. We'll talk about that in just a little bit more, a little more. Straw bale, as I mentioned before, really fun, works great in Colorado. Big, thick, fat walls. We get the straw locally here in Colorado. You can help build it yourself. We do a straw bale barn raising where you invite 40 of your 50 friends, and it's super fun and exhausting. And it makes for a wonderful house, and oddly enough, it's not cheaper than normal construction. The reason is because even though the bales themselves are cheap and your labor is inexpensive, you've now made a wavy wall. And if you ask any tile guy or cabinet guy or anybody who's touching those walls, electricians, plumbers, anybody else, they'll say, wow, that's really hard to work with. We're gonna have to get our best artisans in, not just our lowest paid guy, but our best, most knowledgeable tile guy or cabinet hanger to work with a wavy wall. So you're making something that's very custom, very handcrafted, essentially. But it's wonderful. Once you get in there, the quality of the space just feels incredibly calm, and it's a very non-toxic product. The straw bale also lasts incredibly long. It's also fireproof, oddly enough, and is incredibly structurally strong. The downside is if you ever want to modify the envelope of your house, you're out of luck. I tried taking down a straw bale wall once. It was impossible.
Scott, on that note too,
Yeah.
in November we're going to be doing a straw bale brown bag.
Oh, terrific.
So you want to know more about straw
You're
bale.
making brown bags out of straw.
Brown bag is the name we have for lunchtime seminars where you bring your own lunch, and a speaker like this comes in and tells you all about it.
Are the most successful straw bales with a timber frame support for the?
There are several different ways to do it. You can do load-bearing straw bale if it's a single story. You can do a post and beam. That this project that you see right here actually went up 2 stories, where it's a post and beam frame that carries most of the load, and the straw bale is just an envelope that's attached to that frame. And then there's a third way that's a hybrid, where you actually put studs in the walls, where you take plywood and you make giant fins, and you put them between the bales, and you use this hybrid system of essentially wood-framed walls with straw bales holding up those wood-frame walls. There are lots of different ways to do it. There's a group called COSBA, the Colorado Straw Bale Association, that's a great source for information about straw bale building techniques. Colorado is actually one of the leading states in the whole country for straw bale. So think of this like a percentage. This is the amount of UV radiation that comes through the film, the low E film. If you have a solar heat gain coefficient of, say, 65%, which is about the highest you can typically get, you're letting 65% of the solar radiation in, which on the south side, if you have proper size overhangs, is a great thing. It warms up your house in the winter, and the overhang blocks out the sun in the summer. On the east side, slightly lower solar heat gain coefficient, and on the west side, super low heat gain coefficient, like 20% or 0.2. The reason is because in the late afternoon, say 4 o'clock in the afternoon, sun comes low in the sky, the ambient air temperature is now as high as it is as any point in the day. You're both inside and outside of the house, it's warm. Let's say it's 80 degrees. Sun comes low in the sky, slides underneath the overhang, because it's really hard to control western sun in the late afternoon, and hits your west-facing windows. Bumps your temperature very quickly up to 85 degrees in the house. What do? You turn on the air conditioner. The single biggest use of electricity in a house is late afternoon air conditioning. So the windows are actually really important in controlling these particular, think of them almost like dials or levers on the windows, will help to control and control the solar heat gain in your house and keep your house thermally comfortable at the same time. And then the quantity of windows, it's important to recognize that the best window is still wildly worse than the worst wall in terms of its insulating properties. So you can't have too much glass. If you've ever been to, if you've ever seen an architectural magazine, they're always showing these beautiful steel boxes with walls of floor-to-ceiling glass from end to end. You can't build that here. You can't get a building permit. You cannot meet your energy requirements. It's impossible. And even if it was possible, you'd have to do triple pane glass with argon or krypton-filled gas inside and 2 panes of low E just to even start to come close to being able to do it. It's just that it gets too cold and too hot here. This is the, going back to the passive solar. Passive solar is a very complicated subject, particularly when it comes to windows. There's a whole science to it. And what this is showing, and I know it'll be a little bit hard to digest in 30 seconds, is that horizontal windows, which are also called skylights, are the absolute worst because when the summer sun is high, a skylight is letting in the maximum amount of solar radiation and overheating your house. We try to avoid skylights whenever possible. The south-facing windows actually perform fabulously, meaning in January and February, it's letting in lots of solar radiation. And then if you have a proper overhang, in June and July, it's letting in the least amount of solar radiation. Does that make sense? Sun's really high in the sky, your glass is here, you have an overhang and shade. And even if there's no shade, it's still bouncing off the windows because the angle of the sun relative to the window is so steep.
So what did you call that?
Which?
The one you just described,
That would be the south-facing windows.
south-facing.
This is why we try and put the vast majority of windows in a really good green home facing south, which is not always possible because often your view is to the west or the north or the east or some other direction. But we change the design for sustainable design. Whenever an architect or a builder is looking at creating a house or modifying a house for you, they're going to look at a bunch of factors: budget, schedule, the functionality and flow. But they're also, in this particular case, going to look at the sustainability or the energy use in a house. And in order to do that, they have to say, well, we're going to override certain things. You may have this giant mountain view to the west, but instead of having floor-to-ceiling glass side to side on your house, we're going to have a window. Really good window that looks right at the mountain, but it's the quantity of glass. So you're going to have less west-facing glass because you can't control the heat. We're going to take as much of the glazing as possible, as much of the windows as possible, and put them on the south because that's where we're going to get better energy performance. It's all a matter of priorities when we design and build, and in this particular case, we're prioritizing sustainability over just the views or other factors that, like privacy, that most people consider when building a house. So it's a different way of thinking about design. Then down here you can see that the east and west, in general, it's not so good. It's not as bad as the skylights, but it's not nearly as good as south. And the north windows doesn't make so much of a difference at all, simply because north-facing windows don't get much direct sunlight any time of the year, except right around June and July. So this is what I was talking about before. Solar heat gain coefficient is how much of the solar radiation is allowed through the window, and the U factor is the rate at which the material conducts heat, the thermal transmittance. So we talked about passive solar, or we mentioned it several times. This is a passive solar house that we designed 18 years ago. It's one of the first projects that we did when I opened the firm. It's a straw bale house, and it uses Septs and insulated concrete forms. We basically used every green building technology in a single 1,200 square foot cottage. But what you can really see here is this is in the winter. And you can see how much of the sun comes in through all of these windows. In the summer, this entire face of the house, the south face of the house, is in shade. And that's just the nature of passive solar design. If it's done right, with the right placement of windows and the right overhangs, the right kinds of windows, you have almost no solar heat gain in the summer and lots in the winter. This is a diagram of how it works. This is a section through a house. This is a house up in North Boulder called the Solar Harvest House. Wonderful project. Solar panels all up on the roof, big greenhouse in the front, and it faces due south. So these are the south-facing windows. And it's really a good example of a house that was designed purely for passive solar. This is a diagram of a similar kind of house where we're looking at the sun coming through. This is the overhang that's protecting it. We then capture the heat. The more massive a material you use inside the house, whether it's walls or floor or big planters or rain barrels, whatever it is, if you can have a massive material that can capture the solar radiation directly, you're able to store the heat inside the house. So both of these are examples of good passive solar designs, as long as that's the south side and that's the south side. And you can see how the winter sun comes all the way deep into the house and warms up the house, but the summer sun is blocked. Any questions about passive solar?
I've heard from some other people that you kind of have to choose by the angle of your overhang,
Yep.
whether you want sun in April
Yep.
or May
That's exactly right.
or June, and you have to kind of give and take.
So when I was talking about holistic design before, it's important to realize that there is no one perfect formula. If you have a house that has a let's call it a concrete floor with radiant tubing in it, you can absorb a lot more solar radiation than if you have a wood floor with nothing underneath that has a low thermal mass. So just know that with a wood floor, you'd probably want to reduce the size of the windows a little bit, even on the south side. Or you might increase the size of the overhang to decrease the amount of sun that comes into the house because you can't capture it and hold it. It'll heat up the air very quickly. And then in the swing seasons, you might even have to turn on air conditioning. But if you have a thermally massive floor or a radiant tubing in the floor, you can capture a lot of solar radiation and it'll heat up the house very, very slowly. So you won't need to use air conditioning. So again, it's a holistic design process. This is a plan view. So if you're a bird looking down on top of the house, this is south down here. This is the arc of the sun, or the path of the sun in the summer and then in the winter. And you can see that we have big overhangs on the south, trellises and big porches, solar panels on the roof facing south. And this is again that same diagram where we're orienting the house primarily to be able to accommodate the sun. That's what passive solar is all about, to take in the right amount of sun at different times of year. Passive solar design in Maine and Portland and Florida and Colorado are all completely different. In Maine, you want to capture as much sun as you possibly can because it's really cold in the winter and they don't have a lot of sun. Here in Colorado, it's actually much more about solar protection. If you look at the houses that were built in the 80s here in Colorado, most of the passive solar design actually came from the East Coast, and people were using the models from Maine and Massachusetts. So they tended to overglaze the houses. The windows were too big, and the houses tended to overheat. So over time, we've learned more and more that we need to reduce the amount of glazing, which also happens to improve the energy efficiency of our envelope, because walls are always better than windows. This is just another diagram talking about, in general, how much windows you want to have. If you have a 1,000 square foot house, you don't want to have more than, say, 120 square feet of glass on the south side, 30 square feet on the east and west, and only 10 square feet on the north side. These are rules of thumb. We break them all the time. There are ways to compensate for all of these. Somebody may have bought a house for the big west-facing views, in which case we might have 10% glass facing west. But just know that we're going to compensate in our design for those things. This is ideal passive solar design.
Can you keep that up for a second?
Sure. So we're looking for big windows on the south, smaller, narrower windows at the east and west, and tiny windows on the north. Again, this will be on the CGBG website by the time the tour happens. Daylighting is part of passive solar, but it's not. Passive solar tends to be more about thermal controls. This is more about if you have, what's the most energy efficient light bulb?
It's the sun.
One that's off.
None.
Exactly. So if you have good natural daylighting, you'll notice in this picture, there are no lights on. But the daylighting in this space is really wonderful. Good daylighting usually means light coming from two different directions, so that when you're looking at someone's face, one person is not in silhouette and the other person is in glare. You're actually getting good daylighting all around. And the higher up you can bring the light, typically the better the lighting is. When you have windows on two different sides of the room for good natural daylighting, it also happens to do a second thing, which is create opportunities for passive ventilation across the space. So if you have two operable windows, all of a sudden you open both windows and you don't have to turn on air conditioning because you have a nice flow of air in the summer. Another aspect of solar is solar thermal. It's honestly just as good as solar photovoltaic, but it's much less common. And there are a couple reasons for that. One, it's not quite as sexy. Two, it tends to break. Solar photovoltaic, solar panels, solar electric panels, have virtually no moving parts and nothing that can break. You put a solar panel in place, it stays there for 20, 25 years, and it continues to produce electricity day in, day out. Over time, the productivity diminishes slightly, but for the most part, there's no servicing required. Solar thermal, on the other hand, you are pumping water or liquid medium up to the roof onto essentially, there are two different kinds. One is a black plate like this, the other are round tubes. But you're pumping it into a chamber, sun is heating it up, and then you're taking that solar thermal energy and bringing it back down into the house and then transmitting it to the rest of the house to warm up the house or heat up domestic water. When you do that, you've got pipes that can leak, you have pumps that can break. Not difficult. This is something that most plumbers can handle, but as compared to solar photovoltaic, there are opportunities for it to fail. That said, there are federal rebates for this. It's a fairly inexpensive system, and it's a way to get essentially free domestic hot water for the house. Most people use it for domestic hot water, what comes out of the taps, rather than heating, because for heating a home, you need a huge array of solar panels, whereas for domestic hot water, you only need a few. This is the other kind I was talking about, the evacuated tube collectors. Interestingly, solar photovoltaic panels generally want to be at a fairly low angle to maximize production over the course of a year. Solar hot water panels want to be at a very vertical angle. Anybody know why? Sun's high up in the sky in the summer, low in the winter. When do you need, you only need a certain amount of hot water fairly constantly throughout the year. So you want to angle your panels to maximize production in the winter, like this, when the sun is low in the sky, rather than when the sun is high in the summer. Because otherwise in the summer, you'll have 10 times as much solar hot water as you need. In the winter, not enough. So maximize it for when you have the least amount of sun available in the winter. And that's how you size your system. Just so that you know in general how it works and what it is, we have solar panels on the roof. Price has been dropping through the floor, similar to the way that LED panels have been, or LED light fixtures have been reducing in cost dramatically over the last decade, is that between a combination of federal rebates, some state rebates, and credits from, or rebates from Excel, that the cost of solar panels right now is about 50% of the actual cost. Meaning if you're buying $20,000 worth of panels, after all the tax credits and rebates, you're looking at an out-of-pocket net cost about half of that. So it's actually a really good deal. And what the government is doing is essentially subsidizing a fledgling industry until it becomes mature. But you'll know that if you've seen any of the news that Excel and federal government are all looking at ratcheting down those rebates because solar energy is finally getting to the point where it's a fairly mature industry and is able to compete on a dollars per watt basis with conventional electricity. One of the nice things about it, there's grid tied and then there's off grid. Grid tied is what's called net metering, meaning that Excel is required to give you a meter that runs forward and backwards. So if you generate electricity, you're dumping energy into the grid and it gets transmitted all around to your neighbors, to people halfway across the state. And that decreases the amount of additional energy that Excel needs to create. So they're incentivized because they don't have to build the next $650 million coal-fired power plant. So they take some of that money and they give a little bit to everybody who puts solar panels on the roofs because it decreases their infrastructure costs. This is a solar inverter. Solar panels create DC power. You need AC to run all the things in your kitchen or throughout your house. So this inverts the energy. And in general, for a typical, what's called a 3,000 square foot house, which is about the average size house built in America these days, you need somewhere typically between a 5 and 7 kilowatt photovoltaic system in order to run 100% of the electricity in your house. That'll vary depending on how you use your house and what sorts of things you have in it, and particularly if you have an electric car charger in your house. We have a client that we built a regenerative house for a couple of years ago. They have 10 kilowatts of photovoltaics on the roof. They charge their electric car from the roof, and they get a check back from Excel every month for $120. So that's the definition of a regenerative house. It's measured in your utility bills. So it is possible to have an all-electric house these days.
That inverter, how efficient is it? What amount are you getting?
I don't know. Do you know?
It's quite efficient, you're not losing, it's not like a big loss,
Yeah. Don't know the energy efficiency conversion. We talked about Energy Star.
Above 90.
Above 90? Yeah, I just don't know where it falls exactly. But we talked about Energy Star before. Again, look for that. Look for that blue label, but just note that even within the Energy Star rating, there is a spectrum. So you're also going to be looking for this, which predicts your annual average energy usage. I mentioned before the idea of cross ventilation. There are a lot of low-tech ways to cool your house, especially because it gets cool here at night. You can do a passive night flush where you open up your doors and windows and you draw air into the house. You can use a whole house fan. You can use individual room ceiling fans. You can do cross ventilation where you're able to actually take airflow across a room like that. And there are lots of different ways to bring air through, including what's called the stack effect. If you have a multi-story house, that you can bring in cool air low, and then through the use of a whole house fan, you can ventilate it up and out through the attic. So drawing cool air in and letting the hot air rise, and stack effect, so it stacks upwards and floats out of the house. And these are low energy ways to cool the house as opposed to air conditioning. For mechanical systems, we have a bunch of different techniques. Ground source heat pump, which is sometimes called a geothermal system. Geothermal means steam is bubbling up out of the ground, but it's the colloquial term for a ground source heat pump. Ground source heat pump is this diagram. It takes a device and pumps a liquid medium down into the ground. Once you get below about 4 feet in the ground, the earth stays about 55 degrees all year round. You are leveraging the normal constant temperature of the earth to dump either heat or cool into this liquid medium. So this actually works a lot similarly to the way your refrigerator does. Your refrigerator has coils on the back, and if you feel the back of the fridge, it's a heat pump. It feels hot behind your fridge, and that's what enables you to cool the inside of the fridge. This is a similar technique in that you're taking this liquid medium and you're extracting therms up out of the ground, or you're dumping therms into the ground. And then you can either use a radiant system to have a radiant loop field in your house, or you can blow it through a conventional duct system through your house, in which if you do the air system, you're actually able to both heat and cool your house using a geothermal system. Geothermal is, if you're building a net zero energy house, this is about the only way to get there because it is so energy efficient. There's something called the coefficient of production, which says for every unit of energy you put in, how many units of energy do you get back out? A furnace that is 95% efficient, which is about the most energy efficient furnace you can get, says that for every 1 unit of energy in, you get 0.95 out, 95% back. A ground source heat pump system is 400 to 450% efficient, meaning every unit of energy you put in through the pump energy, electricity runs the pumps, delivers the medium into the ground, you get back 400%, which sounds impossible. It sounds like a perpetual motion machine, but what you're really doing is just borrowing therms from the earth itself. So it's an amazing system that works really well. It is very expensive. In a typical house, it might be $70,000 versus a conventional mechanical system might be $25,000. It's pricey. But over time, it does pay back. It's a very long period of time at this point because our energy prices here in Colorado are actually still quite low. But in certain parts of the country, for those of you who have seen things like oil price spikes, if you've used home heating oil, if you live in the Northeast, and my dad saw a 50% increase in home heating oil costs last year. 50%. So just know that something like this is future-proofing your house, because one thing that we do know is that we have more people using more energy every year. And as the supply, or as the price of energy, or as the demand for energy increases, we know that the price of energy is also likely to increase. So this is a way to protect yourself. It's an insurance policy against future energy costs. Yeah?
Scott, in Colorado, are there any restrictions that would not allow you to build one of these?
No, as a matter of fact, we have huge incentives. There's a 30% federal tax credit, and there are a wide variety of rebates and tax credits from a number of sources, including Excel, for the most energy efficient equipment that you can get out there. So there is a huge federal tax subsidy, or federal tax credit, for using something like a ground source heat pump. But it is pricey. This is not for inexpensive housing. These are for homes that are shooting for net zero energy and are willing to pay for it. This is called, this guy here is an evaporative cooler. On the other end of the spectrum, this is a very low cost item. It runs on a typical house somewhere between $3,000 and $4,000, as opposed to conventional air conditioner, which runs between $3,000 and $8,000, depending on where on the spectrum of energy efficiency you go. But a conventional air conditioner that you see sitting on a pedestal outside behind someone's house, the most energy efficient version of a conventional air conditioner doesn't even come close to an evaporative cooler. An evaporative cooler passes water over a essentially a screen, blows air onto it, and through the natural phase change properties from gas to liquid, it drops the ambient air temperature around that evaporative cooling process, and then it blows the air into your house. So what you get is cool, moist air. A typical evaporative cooler is about 70% more energy efficient than a typical air conditioning unit. So it's a little less expensive than a conventional cooling unit, and it uses 70% less energy over the course of its life. So this is one of those easy things. If you're doing air conditioning in the house, this is a great way to do it. The only drawback is you can't distribute it around the house as well, meaning you can dump it into a central space and then you open up your doors and windows to draw the air, the cool air, into those spaces. Whereas with a conventional air conditioner, you run it through ductwork. Make sense? So we love evaporative coolers when we have something like a central stairwell in a fairly small or compact house where people are willing to open up the doors and windows. This is part of that holistic design that I was talking about at the beginning. We ask our clients, how are you willing to operate your house? If you want to push one button and have the whole house get cold, air conditioning is probably a better way to go. Or if you're willing to spend the money and want a net zero energy house, we're going to recommend that you do a ground source heat pump. But if you're willing to actually do a little bit of manual operation of your house, think of it like those who are willing to drive a stick shift, something like an evaporative cooler is a terrific way to go. There are some other ideas up here. On-demand hot water. Rather than storing, this is particularly good for if you have a very small house, so you don't have much square footage, or if you have a house that's, say, up in the mountains that's a vacation home that you're not in all the time. You don't necessarily want to create hot water and leave it sitting in a hot water tank where the heat just bleeds away for long periods of time. So an on-demand hot water heater is a small device that you can put into a smaller area, and it generates hot water when it's needed and only when it's needed. SEER is an energy efficiency rating for air conditioning units. So if you're going to do a conventional air conditioner, you want to get it up as high as you can. SEER 18 is a pretty good air conditioning rating. The lowest air conditioner ratings right now are about a SEER 13.
Oh, I have a question.
Yeah.
Go ahead. She had a question before I. Oh, did I? Okay. Well, I'll ask it. On the on-demand hot water,
Yep.
does that, in terms of getting how much water it uses before the hot water comes out of your faucet?
Yeah.
I was under the impression that the on-demand hot water ones actually use a little more water than what you've got.
So I've got a better solution than that. Very inexpensively, you can install what's called a recirculation pump. It's inexpensive to install in new construction. It's harder with retrofits. With new construction, you can install this little pump that recirculates the water through your hot water lines so that you don't have to, if you have a mechanical room on one end of the house and a bedroom and bathroom on the other end of the house, you don't have to turn on the water and wait for 2 minutes for the water to get over there. It's already over there because it's constantly moving at a very slow velocity through the pipes in your house. So you turn on the water and 3 seconds later, hot water.
And that can work with either the on-demand
Yeah.
or the regular?
Yep.
I have an on-demand
Mm-hmm.
water heater, and it's gas.
Mm-hmm.
Is there an electric one?
There is, and you don't want to do it. It will wreck your energy efficiency. It's one of the most energy intensive things you can possibly put into a house.
Okay, and I was going to say, what I do is I get a bucket. My kitchen is further away from this thing than the bathroom and the shower and all that. So I put a bucket in the sink, and then I haul it outside.
Yep.
It's warm, and I throw it on.
This is a great low-tech eco way to make use of the water that you're running in order to get your hot water. Is lots of people actually do that. They put a bucket there, not lots, but people that are very environmentally minded will put a bucket there, take that water and water their plants with it. Yeah. That's the low-tech version of recirculating pumps. An ERV, or an HRV, energy recovery ventilator or heat recovery ventilator, this is something that is new and really important and special. Remember we talked about holistic design again. If you seal up a house really tightly to make it super energy efficient, and you've got products that have some toxic off-gassing, because every house has some toxic off-gassing, whether it's the paint, the carpet, the cabinets, the flooring, whatever it is, the plastic around the light fixtures, there's always a little bit, even in a good green home. When you seal up a house really tightly, you don't have fresh air naturally infiltrating the house. Old houses are naturally drafty, but they naturally recirculate in fresh outdoor air. Not in the good way, because you're not controlling when and where it's coming into the house. But with an ERV, if you seal up the house tight, then you have to ventilate it right. And what that means is you have this device that tempers the air as it comes into the house. It's almost like there's a radiator grill where warm air or air that is conditioned to 70 degrees inside the house is passing along this plate. And let's say you were sucking in 10-degree air on a cold winter night from outside. It exchanges the therms from the warm air through this plate into the air that's coming into the house. So it tempers the air and can dramatically reduce the energy loss from bringing in fresh air into the house. Because you do have to mechanically introduce fresh air into the house so that you don't have sick building syndrome or just a stuffy house. We have high efficiency wood burning appliances. Here in Colorado, we have EPA Phase 3 compliant, which means that there's very little particulates and that it tends to reburn the material, so you get a lot of heat brought into the house with very little pollution expelled into the atmosphere. We're going to fly through the rest of these because we still got a little more to go. Indoor air quality. As I mentioned before, Americans spend 90% of their time indoors. These are somewhat old numbers, so I think they've improved a little bit, but most houses actually contain a lot of toxic off-gassing materials. Formaldehyde is the most common one, and as you guys know, formaldehyde is found in so many different particle boards and plywood cabinets. You can get things that are rated, that are certified no added formaldehyde wood products, NAF products. You can also get products that have no formaldehyde in them. But formaldehyde is a naturally occurring thing. It occurs all throughout nature, so any wood product actually has a little bit just naturally. But the binders and resins that are used to put particle boards and plywoods together typically have very elevated levels of formaldehyde, as does floor finish, paints, and almost every material that comes into the house. When you have a very tightly sealed house, you can create a really toxic soup environment. And interestingly, the place where we really paid attention to this is children. This is one where the market, moms in particular, raised holy hell and said, oh my God, I'm getting migraines. I have a suppressed immune system which is causing fatigue, chronic fatigue and headaches and nausea and all kinds of things, or asthma. And it's not from bad outdoor air quality anymore. Our outdoor air quality is fantastic here. It tends to be from the indoor air quality. So if you've ever walked into a building, there's a lot of furniture stores in particular, particularly the lower end furniture stores. I guarantee if you walk into one of those giant warehouse furniture stores, that you'll probably have similar symptoms to me. I don't have environmental illness. My nose started getting runny, my eyes started getting itchy, my throat swelled up, and that is the off-gassing of those volatile organic compounds. The most common place that most people experience it is new carpet, because there's an enormous amount of surface area, and most carpets off-gas pretty strongly. So if you smell that new carpet smell, that's off-gassing, and it is toxic to your system. The most common thing that it does is generally suppresses the immune system. Most people don't have an immediate asthmatic reaction to it. But what happens is when you combine that with all the other assaults on your particular immune system, it'll suppress your immune system. The most common thing that happens is you get either tired or you get sick easier. So when you go into the office the next day and somebody sneezes on you and your body could normally handle that, now your immune system is under constant assault from the new carpet and new paint and new everything that you put into the house, and it can't resist a normal common cold. So this is just where we try to introduce lots of fresh air. We try to eliminate toxicity everywhere we can in the house. In Boulder, more than half the homes have elevated levels of radon. This is the natural phenomenon of decomposing granite, and we have a lot of decomposing granite. Soil gases percolate up through the foundations, and you've probably seen those white plastic pipes that snake up the outside of buildings. That's a remediation technique. You don't have to do it in that ugly way, but it is a way to draw the radon gases out from underneath your basement slab and up past your roof. It's an easy thing to test for. You go to any hardware store, or at least McGuckin's has it, little packets, and for $10 you can get a radon testing kit. In 48, you open it up, put it in the basement, and in 48 hours you know if you have elevated levels of radon. Radon is carcinogenic, and it is very serious, particularly if you smoke. It bonds with nicotine molecules and lodges in lung tissue, so it causes lung cancer like crazy. Other things to look for are asbestos. Asbestos was very common in building materials. Matter of fact, it was required by law until about 1978, and then it became illegal. And the reason is because it was a miracle product. It made every product better, fireproof. It made paint spread better. It made everything stronger. It was wonderful, except that it's going to kill you. It's not dangerous if it's encapsulated. So if you go into a house and you've got something like those checkerboard flooring tiles in a basement built in 1956, that is almost certainly asbestos material. But you don't have to do anything to it, because as long as it's not particleized and airborne, it's not going to get into your system. So you can encapsulate it. You can put paint over it. You can put carpet over it. If it's popcorn ceiling, I'd worry a little more, because it can become friable, airborne very, very easily. So if you are putting a new planter hook into the ceiling, that dust actually is likely to get inhaled. It's extremely carcinogenic. But as long as you're not doing anything to a house, you don't have to remediate it. It has to be remediated by a professional. Legally, you are actually allowed to do it yourself. I strongly advise against it. It's dangerous. So if you're doing a major remodel, you have to get your house hazardous materials test for your house. A company comes along, does a little scrape. 2 weeks later, you'll find out how hot your house is, meaning how carcinogenic the materials of your house are. Lead is a little bit less dangerous, mostly because you have to come into direct repeated contact and then ingest it. So little kids running their hands down a banister and then touching their face is a pretty common way for lead to be a serious thing. It's actually a very serious material, but it's hard to get it into your system, much harder than asbestos. Mold and mildew is actually surprisingly common, but it's easy to remediate. A moldicide or just bleach, sunlight, air will kill the mold. But do know that if you have mold or mildew, you actually have a moisture problem and you need to solve that. So look for things like downspouts on the outside of a house that are not being diverted away from the foundation. Look for things like leaky water pipes inside of a house. These are some of the different ways to deal with various indoor air quality. I just love this photo because these guys are in total hazmat suits, and this guy is Superman over here. It's completely immune to all of it. This is Denver 25 years ago. This is what we used to have. Outdoor air quality used to be far more deleterious to our health than indoor air quality. We have fixed this through different controls for cars and just the way that we deal with industry and generation of energy. But we're still dealing with the indoor air quality issues. These are some of the things, some of the places where you'll find indoor air quality issues. And then the last one is resource conservation. One of my favorite quotes, "What's the use of a fine house if you haven't got a tolerable planet to put it on?" by Henry David Thoreau. You can find a wide variety of green building materials. Recycled content countertops with recycled glass in them. Recycled content decking. Trex decking is a popular brand of decking, which is sawdust and plastic pop bottles put together. Cork flooring, which is a renewable material where they strip the exterior bark of cork trees off and then it regrows. Bamboo flooring.
Do you have success with bamboo?
Yeah, we do. I've got it in my house. Yeah. All hardwood flooring in Colorado has a hard time. Bamboo is a little bit of a newer product, so it tends to be a little less dimensionally stable than, say, older growth products or more conventional wood flooring. But it does, but really no worse than conventional hardwood flooring. Wood flooring in Colorado it's hard to get it to not gap in general. FSC stands for Forest Stewardship Council. It's a sustainability certification, third-party certification for well-managed forests. Recycled content cellulose, so this is chopped up newspapers. Recycled glass in tiles, engineered lumber, which is made from small, fast-growth trees instead of large, old-growth trees. Fly ash in the concrete that I mentioned. FSC certified framing. Local or local wood like beetle kill, like the floors that you're sitting on right here, or reclaimed wood, which tends to be quite expensive but is really beautiful for feature parts of a house, like a mantle over a fireplace. Resource conservation is also about water. So using EPA water sense fixtures, these are low flow certified fixtures in Boulder. These are required per code. On the exterior, we've got xeriscaping, which just means using native plants, or permaculture, which is the next step up that becomes a landscape that actually delivers things back to you, such as compatible species that help each other to thrive and survive and produces urban gardening. It also means allowing water to actually percolate down into the soil. What we saw in Houston right now was dramatically exacerbated by the fact that they've paved over most of their permeable surfaces. So water doesn't have the ability to percolate back into the stormwater. And what our antidote on the sustainability side is making sure that water can actually infiltrate into the ground and recharge our stormwater aquifers.
Have you done much with permeable concrete?
Permeable concrete pavers like this are wonderful. They tend to be quite expensive though. We've also been doing some stormwater catchment. You are now, for the first time ever, allowed, if you are on a well and septic as opposed to city water, you can capture rainwater off your roof and put it in a cistern, and then you can use it.
See it, you can put it in
Shh, we don't talk about that. In Boulder, it's also mandatory when deconstructing a house or just the waste from your construction is that you have to sort and separate all the products. So if you're deconstructing a house, you actually take the usable products and donate them to Resource, where we're going to be having our ticket sales for the Green Home Tour. And you also get a tax credit because you're donating them as a charitable donation to this nonprofit, and then they resell those usable materials. And when you're building, we also have to sort on the job site, so each of the materials, just like in an office, you have to separate them into the usable areas so we can recycle them.